Okay, we can start. This is the third part of the seminar of the Professor Balash. We have he discussed with us of many issues, climate change and also best practice in a little town and the middle town. Thank you, Professor.
Thank you very much. The students, the colleagues, welcome here, and I am happy that they are here and listen my presentations. I would like to speak about today about the biomass technologies after the climate change and the consequence, the environmental consequences of energy industry, and after that I will speak about the energy policy and the strategies. And finally about energy storage and energy transition. Firstly, the first part of today, the bioenergy technologies. The topics of the lecture is the renewable energy technologies, only the bioenergy technologies, for example, biomass, biogas, landfill gas, savage gas, algae technology, firewood, and pellet. The content of this presentation, first is the biomass. Biomass is plant or animal material used as fuel to produce electricity or heat. Examples are wood, energy crops, and waste from forests, yurts, or farms. The word biofuel is usually reserved for liquid or gaseous fuels used for transportation. Wood and wood residues is the largest biomass energy source today. Wood can be used as fuel directly or processed into pellet fuel or other forms of fuels. Other plants can also be used as fuel, for instance corn, switchgrass, miscanthus, and bamboo. The main waste energy feedstocks are wood waste, agricultural waste, municipal solid waste, manufacturing waste, and landfill gas. Savage sludge is another source of biomass. There is ongoing research involving algae or algae-derived biomass. Other biomass feedstocks are enzymes or bacteria from various sources grown in cell cultures or hydroponics. Based on the source of biomass, biofuels are classified broadly into three major categories. The first generation biofuels are derived from food sources such as sugarcane and corn starch. Sugars present in this biomass are fermented to produce bioethanol and alcohol fuel that serves as an additive to gasoline, or in a fuel cell to produce electricity. The second generation biofuels use non-food based biomass sources such as perennial energy crops and agricultural or municipal waste. Proponents argue that there is a huge potential for second generation biofuels. The third generation biofuels refer to those derived from microalgae. Sorry. The biomass conversion. Sorry, the next. Upgrading raw biomass to higher grade fuels can be achieved by different methods, broadly classified as thermal, chemical, or biomechanical. The first of these, the thermal conversion. Thermal conversion processes use heat as the dominant mechanisms to upgrade biomass into a better and more practical fuel. The basic alternatives are torrefaction, pyrolysis, and gasification that are separated principally by the extent to which the chemical reaction involved are allowed to proceed. The next, the chemical conversion. A range of chemical process may be used to convert biomass into other forms, such as produce fuel that is more practical to store, transport, and use or to exploit some property of the process itself. Many of these processes are based in large part on similar coal-based processes, such as the Fischer-Tropsch synthesis. Biomass can be converted into multiple commodity chemicals. The third conversion is the biochemical conversion. In most cases, microorganisms are used to perform the conversion process, anaerobic digestion, fermentation, and composting. And the fourth methods of conversion, the electrochemical conversions. Biomass can be directly converted to electrical energy via electrochemical oxidation of the material. From this energy source, we can produce electricity and heating as well. The types of biomass heating systems, the fully automatized, the semi-automated or surge bin method, and the pellet fired. You can see on this picture the pellet fired method, and this heating method is full automated version in family houses, village heating, so district heatings as well, and residence heating as well. The next part of the biomass is the biogas energy source. Biogas is a mixture of gases, primarily consisting of methane and carbon dioxide, produced from raw materials such as agricultural waste, manure, municipal waste, plant material, sewage, green waste, or food waste. It is a renewable energy source. Biogas is produced by anaerobic digestion with anaerobic organisms or methanogen inside an anaerobic digester, biodigester, or bioreactor. Biogas is primarily methane, carbon dioxide, after that hydrogen sulfide, and moisture and siloxanes. The biogas plants. The biogas plant is the name of an given to an anaerobic digester that treats farm waste or energy crops. It can be produced using anaerobic digesters. These plants can be fed with energy crops such as maize silage or biodegradable wastes, including sewage sludge and food waste. During the process, the microorganisms transform biomass waste into biogas and digestate. And we can use this biogas in a lot of form, for example, in trains, buses, district heating, or we can pump to the city natural gas network, and we can produce with this energy electricity as well. The next source is the landfill gas. Landfill gas is produced by wheat organic waste, decomposing under anaerobic conditions in a similar way to biogas. The waste is covered and mechanically compressed by the weight of the material that is deposited above. This material prevents oxygen exposure, thus allowing anaerobic microbes to thrive. Biogas builds up and slowly released into the atmosphere if the site has not been engineered to capture the gas. You can see here deponization of the city and the mechanisms from the waste we can produce mainly methane gas. It's a typical gas extraction well on this picture. Okay, the next is the sewage gas. Sludge treatment is focused on reducing sludge weight and volume to reduce transportation and disposal costs, and on reducing potential health risk of disposal option. Energy may be recovered from sludge through methane gas production during anaerobic digestion or through incineration of treated sludge. So, and the high-tech technology today, this is the microalgae energy production. You can see here on this picture microalgae energy producing field in the USA. We can produce this technology maintenance fuels, different fuels. Okay, this was the first part of today. Do you have questions, maybe? Okay, the next issue is the climate change and its consequences. Okay, the topic of this lecture is the energy sector in the range of global environmental problems. Firstly, in this part, I would like to speak about the climate change. What are its manifestations? What is man's role in it? And what are the consequences of inaction? And what can humanity do about the consequences? So, what are the climate change? Contemporary climate change includes global warming and its effects on the Earth's weather patterns. There have been periods of climate change in the past, but the current changes are clearly more rapid and are not due to natural causes, but to emissions of greenhouse gases, mainly carbon dioxide and methane. The burning of fossil fuels for energy is responsible for a large proportion of emissions. Other emitters include agriculture, industrial activity, and deforestation. Greenhouse gases are transparent to sunlight, allowing it to pass through and warm the Earth's surface. You can see on this picture this process. The heated Earth's surface emits heat in the form of infrared radiation, which is absorbed by the gases, keeping the heat close to the Earth's surface. As a result, the planet's lower atmosphere is getting warmer. What are the causes of climate change? Human activity since the Industrial Revolution, particularly the extraction and combustion of fossil fuels, has increased the amount of greenhouse gases in the atmosphere, leading to a radiative imbalance. By 2019, carbon dioxide concentrations will have increased by about 48%, and methane by 160% compared to 1750. Carbon dioxide emissions come mainly from the burning of fossil fuels, deforestation and industrial processes, such as cement production, metallurgy and fertilizer production. For example, China used so many cement in the between 2008 and 2013 than the United States in the whole 20th century. And this is only 5 years. Okay. Yes, methane emissions come from animal husbandry, rice cultivation, landfills, sewage, coal mining, and oil and gas extraction. And nitrous oxide is largely from the decomposition of fertilizers. What are the consequences of the climate change? The environmental impacts of climate change are wide-ranging and far-reaching. Global sea levels are rising due to melting glaciers, melting Arctic ice sheets, and thermal expansion. The increase in dissolved carbon dioxide causes ocean acidification. You can see on this picture this process. For example, the animals, the sea animals, cannot produce so many limestone, which is enough for your safety. Okay, the increase in dissolved carbon dioxide causes ocean acidification. At the same time, oxygen levels are decreasing because oxygen is less soluble in warmer water. The deep zones in the oceans, regions with very little oxygen, are thus getting larger. Many of these effects are already being felt at the current warming level of 1.2 degrees Celsius. Data from the US National Oceanic and Atmospheric Administration shows that the average global sea surface temperature, the temperature of the upper few meters of the ocean, has increased by approximately 0.13 degrees Celsius per decade over the past 100 years. A 2012 paper published in the journal Geophysical Research Letters revealed that the deep ocean is also affected, with 1/3 of the excess heat absorbed 700 meters below the sea surface. Modeling studies published in Intergovernmental Panel on Climate Change's 2013 report predicted that there is likely to be an increase in mean global ocean temperature of between 1 and 4 degrees Celsius by 2100. The consequence is that we will be a large energy in the oceans, and the consequence is the extreme weather phenomena. In India and East Asia, periods of extreme rainfall or flow have increased within the monsoon season. The rainfall and intensity of hurricanes and typhoons are increasing. The greater the rate of global warming, the greater the risk of crossing tipping points. Thresholds beyond which certain impacts can no longer be avoided, even if temperatures fall. Examples include the collapse of the West Antarctic and Greenland ice sheets. Some large-scale changes may occur in the short term, such as the disappearance of certain ocean currents. Of particular concern is the disruption of the North Atlantic current, which would cause major climate changes in the North Atlantic, Europe, and North America. Carbon dioxide stays in the atmosphere for a long time, causing long-term effects such as further melting of ice, warming of the oceans, rising sea levels, and ocean acidification that will continue for hundreds of thousands of years. The impacts of climate change on humans are being felt around the world. Firstly, I would like to show a couple pictures about the ice sheets consequences. You can see on these pictures the melting of permafrost in the northern hemisphere. The main area of this process is Siberia, and after the melting of permafrost, so in the permafrost there are a lot of methane, for example, and after the melting of permafrost, this methane go to the atmosphere, and they produce explosions with this like this picture, and they produce a lot of erosion, for example, on this picture.
For example, what is this kind of?
This?
Yes.
This is the Batagayka crater in Siberia.
Mm-hmm.
And here are more relief on the surface, and the melted ice. From the melted ice will be water, and this produced erosion.
Okay.
For example, this process crashed and fell the houses and buildings as well in Siberia. Okay. Because the simple situation in summer melted the upper 2 meters of the surface, and there are many mosquitoes, for example, and mud and sludge. And after in the winter half year, all is in ice, and in this part of the year can the people build the buildings and the transport and so. And in this situation, they don't have this period or shorter.
Okay.
Okay, and other consequences of the climate change, the desertification, the main areas in the Middle East, in the Middle Asia area, for example. For example, you can see here the Aral lake, and we have this lake only in the map, but today we don't have water in this lake because in the communism's era there are here very intensive agriculture, and this lake has two rivers, the Amu Darya and the Sir Darya, and these two rivers transport fresh water to the lake, and this fresh water used the agriculture, and after that wasn't enough water to the lake, and this will be desert. And this is a salt lake, and this salt accumulate to the ground of the lake. The wind transport this salt to the agricultural areas, and those areas.
This phenomenon, where we can find this kind of phenomena,
here in Middle Asia.
Okay.
Middle Asia, and this area is here. This is the Chad Lake.
Okay.
In the Middle Africa, in the Sahel area. And for example, from this lake, use the fresh water 4 countries, and large cities. And the water area was this in 1963, and today we don't have water.
Okay.
Other consequences, the wildfires, for example, here and in Hungary as well. For example, this summer near Budapest as well. And I live in Debrecen. This is East Hungary. This is located in East Hungary, and near Debrecen we have a large national park, and this national park, this is a Anthropocene area, but we have there a lot of forests and grass fields and so, and we have wildfires as well in this area.
In Sardinia is usually this kind of phenomena. Unfortunately, yes.
Not function. Not work. Sorry, just a moment, please.
Yes.
What can I do?
Yes, yeah.
First, the second.
The second. Yes, because you should close and then.
Okay.
Okay.
Okay, we can hear. Okay, the next consequence, the consequence of the humans. The impacts of climate change of humans are being felt around the world. In warmer climates, infections, diseases such as dengue fever and malaria spread more easily. Both children and the elderly are vulnerable to extreme heat, which can cause premature deaths, already reaching 250,000 a year. Climate change has implications for food security. Future warming could further reduce global yields of major cereal crops. Economic damage from climate change would be severe and is already increasing global inequalities. The most severe impacts are expected in Africa, Southwest and Southeast Asia. The rise in temperature may be so great that people living in these regions will no longer be able to adapt. This will lead to poverty, displacement, and armed conflicts over remaining resources. What responses can we give to these impacts? In 2015, under the Paris Agreement, the world's nations collectively pledged to keep warming well below 2 degrees Celsius. But even with the commitments made under the agreement, global warming would still reach 2.7 degrees Celsius by the end of the century. The United Nations Environment Programme estimates that the Paris Agreement pledges will need to be tripled over the next decade to limit global warming to 2 degrees Celsius. An even greater reduction is needed to reach the 1.5 degrees Celsius target. Limiting warming to 1.5 degrees Celsius requires halving emissions by 2030 and achieving net zero emissions by 2050. This requires far-reaching and systemic changes in energy, land use, urban planning and management, transport, industry and construction. What responses can we give to these impacts? Deep cuts in emissions require a shift from fossil fuels to low carbon sources. This involves phasing out coal-fired power plants, significantly increasing the use of wind and solar energy, switching to electric vehicles, using heat pumps in buildings, rethinking the role of nuclear energy, and taking energy-saving measures. The next is the increasing energy efficiency is another important element in reducing emissions. If less energy is needed, this allows more flexibility to develop clean energy. It also makes it easier to manage the electricity grid, reduces heating and cooling demand, and minimizes carbon-intensive infrastructure development. A further response is to remove carbon dioxide from the atmosphere, for example, through gas extraction based on modern technologies and by increasing forest cover. Adaptation is the process of adjusting to current or projected changes in climate and their impacts. However, without further mitigation, adaptation cannot avert severe and irreversible impacts. So that was the second part of today's topics. Any questions? Maybe. The next part is the energy sector in the range of global environmental problems without climate change. These consequences are global, regional and local as well. I would like to speak about these consequences. Okay, firstly, I would like to speak a couple of words about the environmental effects of the oil industry. Petroleum has many uses, and the environmental impacts of the oil industry are correspondingly extensive. The extraction, refining and transportation of oil and gas generate significant amounts of toxic waste. Some of the industry's byproducts, such as volatile organic compounds, nitrogen and sulfur compounds, and spilled oil can pollute the air, water, and soil to levels that are harmful to life. Oil has made it possible to produce a wide range of consumer goods from plastics at low production costs. Much of the plastics is not recycled, and over time it breaks down into smaller and smaller pieces. These microplastics can be observed in air, water, soil, samples collected from almost every part of the Earth's surface, and increasingly in biological samples. You can see on this picture National Park of Croatia. For example, in this national park and in the Lake Plitvice, this is a very clear area, but there are a lot of tourists. For example, I was there before 2 years ago, and before 2 years, they limited the tourists per day. For example, in this situation, 10,000 tourists per day. These tourists are very clear and no problem with the tourists, but they have here waste as well. And this is a big problem. You can see in this picture as well, in these situations. So these microplastics we can find, for example, in the Antarctica as well. Yes. The microplastics can be observed in air, water, soil, samples collected from almost every part of the Earth's surface, and increasingly in biological samples. The long-term effects of the accumulation of plastic waste in the environment are being scientifically assessed, but are still mostly unknown. Microplastics are of concern because they tend to bind and accumulate pollutants. The next problem of the oil industry is the acid rains. Burning oil, coal, and wood causes increased amounts of nitrogen oxide and sulfur dioxide. The concentration of nitrates and other acid changes the pH level of the rain. These byproducts combine with water in the atmosphere to create acid rain. Acid rain destroys the ecosystem, destroys coral reefs, corrodes machinery and structures, and destroys monuments. You can see here trees killed by acid rain. This is in Cheshire, in Czech Republic. And you can see here monuments which have a problem with the acid rain. This limestone and sandstone melted from the acid rain. The oil sand mining. You can see oil pits from Canada. Mining activities release large amounts of pollutants into the water and the atmosphere, such as dust, heavy metals, or chemicals. Surface mining is the most destructive of all, leaving irreparable scars on the landscape. Oil spills. The term oil spill is used to describe marine oil spills, where oil is released into the ocean, but can also occur on land. Major oil spills include the Gulf War oil spill or the Deepwater Horizon oil rig accident. Spilled oil penetrates the feeders of birds and the fur of mammals, reducing their insulating properties. Very oil from vehicles drips from engines onto roads and from there into groundwater containing it. You can see on this picture the first oil transport disaster of the world. This was in the 1980s decade near Alaska, and the technicians have to wash the coast with hot water 100 kilometers long. And the problem was here that the captain drank a lot of alcohol. And this, you can see on this picture the war effects of the Gulf War. This is the Iraq. This is the Kuwaiti oil field, the main Kuwaiti oil field. This is 40 kilometer times 20 kilometers area, and here were 530 oil drill. And this is interesting. This is a Hungarian idea, because this bird oil spill is very hot. They cannot go to the earlier area of this drill, and they cannot do the water or send to this burned oil drill. And this engine, this is a tank platform and two jet engine, and the jet engine blows the water to the foyer. And this was very good idea in this situation. You can see on this picture the Deepwater Horizon disaster in the Mexican Gulf in 2011. This was the biggest oil spill disaster on the world. And the problem is this, because we can search the oil spills in the face of the ocean, but this down under 1,000 meter deep, we cannot search this oil from the ocean. Okay, the next part, the natural gas industry effects. The biggest environmental impact of the natural gas industry is the release of methane and carbon dioxide into the atmosphere, which are potent greenhouse gases. Human activity is responsible for about 60% of all methane emissions. The extraction of natural gas leads to reduction in reservoir pressure. This reduction in pressure can lead to subsidence of the ground above. Subsidence can affect ecosystems, water causes, sewerage and water supply systems, and building foundations. Failure of gas simple systems can result in gas lakes, into living spaces, causing poisoning and explosion hazards. The release of natural gas form subsurface porous rock formations can be achieved by hydraulic fracturing. The process involves pressing water mixed with various chemicals into the rock. The high pressure water breaks up the rock, releasing gas. The process involves the use of toxic carcinogenic chemicals, benzene and ethyl benzene in the water, mixtures used in the cracking process. The chemicals are difficult to remove from the water to stay severely pollute the water cycle. The next energy source which have environmental effects. This is the coal industry. The health and environmental impacts of the coal industry includes issues such as land use, waste management, water and air pollution. In addition, the atmospheric pollution, coal combustion generates hundreds of millions of tons of solid waste each year, including fly ash, bottom ash, and flue gas disulfide sludge, which contain mercury, uranium, thorium, arsenic, and other heavy metals. Coal is the largest contributor to the increase in atmospheric carbon dioxide. Surface mining disrupts virtually every aesthetic element of the landscape, severely altering the landscape and reducing the value of surrounding land. Populations are displaced from the mine site, wildlife disappears, agricultural activities disrupted, and the water is polluted. You can see on this picture the Mpumalanga high veld in South Africa, in the most polluted area in the world due to the mining industry and coal plant power stations. The next energy source is the nuclear power. The environmental impacts of nuclear energy arise from the nuclear fuel cycle, operation, and the effects of nuclear accidents. Greenhouse gas emissions are much lower, and health risks are also lower. However, there is risk of catastrophic failure due to the melting of overheated fuel in nuclear reactors and the release of large quantities of fission products into the environment. This potential risk could negative the benefits. The longest-lived radioactive wastes, including spent nuclear fuel, should be isolated from the environment for long periods. You can see on this picture the consequences of the Fukushima disaster. For me, I don't understand because this area has a lot of earthquakes and tsunamis as well, and this nuclear power plant stay in the coast. And for example, that they built this power plant, for example, 5 kilometers from the ocean. They can use the ocean water to the cooling, but the power plant located widest from the ocean problems, for example tsunamis. And this is the Chernobyl disaster. The consequences were by us as well. For example, in Hungary, we could measure the pollutions. The longest-lived radioactive waste, including spent nuclear fuel, should be isolated from the environment for long periods. On the other hand, spent fuel could be reprocessed, which would generate even more energy and reduce the amount of waste to be contained. However, this technology is not yet available. For example, you can see here the open Rhine Valley, and here are geological. Here are two geological lines, and this is dangerous for the Fessenheimer nuclear power plant as well. In Hungary, there is only one nuclear power plant, but that is dislocated in the middle of Hungary. But we have the main structural line under this nuclear power plant as well.
This line of the structural line is.
This is Germany.
Okay.
This is the Upper Rhine Valley.
Okay.
It is the Rhine, and here are two structural lines, and here is the Fessenheimer nuclear power plant. Okay, the next, the waste incineration and the environmental effects. Incineration poses a number of problems, such as the release of ash and flue gases into the atmosphere. Before the flue gas cleaning system, the flue gases can contain heavy metals, dioxins, furans, sulfur dioxide, and hydrochloric acid. If the flue gas cleaning of plants is inadequate, these emissions can cause significant pollution. The next effect from the solar power industry. Unlike fossil fuel-based technologies, solar energy does not produce emissions during operation, but the production of the panels does produce some pollution. Solar energy requires much more land to produce the same amount of energy than higher surface power density sources. The occupation of such large areas will lead to the removal of vegetation and the conversion of agricultural land, which will provoke public opposition. Solar panels have an average lifetime of 20 years. After that, recycling must be ensured because they contain toxic substances such as lead, copper, and cadmium. The next, the environmental effects of wind farms. The environmental impact of wind energy is considered small compared to fossil fuels. Compared to other low carbon energy sources, wind turbines have one of the global warming potentials. Onshore wind farms can have a significant visual impact on the landscape. The network of turbines, feeder roads, transmission lines, and substations can create an energy sprawl. Wind turbines also generate noise. Prior to 2019, many wind turbine blades were made of fiberglass, with designs that offer the lifespan of only 20 years. Old blades are now dumped in landfills because there is no recycling technology for the materials. You can see this. You can see this problem on this picture. The next is the biomass, the environmental effects of biomass. Environmental impacts vary considerably between different biomass energy sources. Biodiversity should be seen as an objective of the green economy in the same way as curbing greenhouse gas emissions. The low surface area power density of biomass means that much more land is needed to produce the same amount of energy compared to fossil fuels. The low surface area power density of biomass means that much more land, the problem is compounded if only part of the crops are used. This is the case for the production of liquid fuels. That is produced from the sugar content of sugar cane or the starch content of corn, while biodiesel is produced from the oil content of peas and soybeans. The next is the environmental effects of geothermal energy generating. The construction of power plants can adversely affect soil stability. For example, subsidence has occurred in the Veilakai field in New Zealand. At Staufen im Breisgau in Germany, on the other hand, tectonic uplifts had taken place as a previously isolated layer of anhydrite has been exposed to water and turned to gypsum, doubling its volume. Artificial geothermal systems can trigger earthquakes during hydraulic fracturing. Okay, this was the environmental effects of the energy industry. You could see here in this presentation the regional and the local effects of the energy industry. Do you have any questions? Yes?
From the point of view of greenhouse effect, which is natural gas or exhaust gases from waste combustion more dangerous?
I don't understand, sorry. Can you repeat?
From the point of view
Yes?
of greenhouse gases,
yes?
Is natural gas or exhaust gases from its combustion more dangerous? Atmosphere.
The methane is stronger as the carbon dioxide because the methane is 28 times aggressive greenhouse gas than the carbon dioxide. And if we burn this methane, this biogas, for example, from agriculture, if we have a lot of cows, this produces the methane producing 30% methane producing comes from the agriculture. 30% methane producing comes from the agriculture, and if we generate from this methane electricity and for example district heating, we can do lower this greenhouse gas emission to the atmosphere. But the best solution if we use zero emission renewable energy sources, for example, solar, geothermal, and wind energy. For example, we can pump this biogas to the network, to the city gas network as well, or we can pump to this network hydrogen as well. We can do from the overproduced wind energy or solar energy from the water hydrogen, and we can pump to the network. This is a pilot project in France, in Dunkirk. There pump, I think, 10% of the district gas from hydrogen. But this is the natural gas or methane.
Thanks.
Okay. Good question. Can we hold
maybe a little break?
Little break?
Would you like a little break? Okay.
Okay. Thank you.